Action.
Hi everyone. So my name is Joreen Arigye. I'm going to take you through a simple introduction to machine learning and more specifically supervised learning. So this is going to be the structure of the class. I'm going to do a simple introduction using already written out blogs. We shall just try to read through it and see how we can understand together. Then I will take you through some practical examples through which machine learning is applied in the industry right now. And then we shall go to real supervised learning algorithms, try and understand them. And then we shall go through a simple tutorial of how you can actually write a model from start to finish. And then we shall see how we can evaluate your model. So that will be the structure of the class. All right. So let's start with this tutorial written by Joseph Roca. And then it says a simple introduction to machine learning, okay? Okay, so let's go right there. So we shall just read through and then I'll just be breaking and trying to explain the concepts. I find that that is a better way for me than slides. All right, so this introduction says we are currently living in a data era with vast amounts of data, where vast amounts of data is collected and stored every day. In the face of the growing quantity of data, machine learning methods have become inescapable. So this is just really an introduction, and by the mere fact that you're interested in even this class, you can see that machine learning methods have become inescapable. So much so that you probably use dozens of them at a time without even noticing. So let's start with an example from everyday machine learning, contribution for millions of users, okay? So this example is the algorithm behind Facebook's newsfeed. Facebook uses machine learning to exploit users' data and feedback to personalize their feeds. If you like a post, okay, if you like a post or stop scrolling to read something, the algorithm learns from this and starts to populate your feed with similar content. Yeah, so like you see how your content on Facebook is very specialized to your likes. So you will stop and like something, you'll stop to scroll something, you'll find that similar things will be coming up. So that is a machine learning algorithm in the back end, specializing your news feed for you. All right. So this learning is done continuously, and so the material suggested for your newsfeed evolves with your preferences, making your user experience more enjoyable. So that's why I think that is among the reasons why Facebook is, you can be quite hooked to it, because it keeps giving you things that you're probably interested in. Yeah. All right. So he continues to say, this is only one example. There are many others. Apple can recognize your friend's face in your photo that you just took. Amazon Echo understands you and can answer your questions. Your vacuum can even navigate its way around your house, while Netflix is recommending videos that match your profile. Machine learning has become a massive part of our daily lives, and it's not going anywhere. So this is just trying to give you simple examples of how machine learning has been really used practically in people's lives. Face recognition, voice assistant, vacuum robot, movies suggestion, that's Netflix. So let's go into and define really what is machine learning. Okay, according to John. So he says, what's behind the magical looking algorithms and how do they use data so well? So formally, machine learning is a science of getting computers to realize the task without being explicitly programmed. I think that is a very easy way to understand it. So you're getting a computer to realize a task or to execute a task without explicitly telling it how to execute that task. So in other words, the big difference between classical and machine learning lies in the way we define them. So classical algorithms are the normal algorithms that we use, and then now we're going to learn about machine learning and how machine learning algorithms operate. Okay, so we just said that machine learning is the science of getting computers to realize a task without being explicitly programmed. I think that is really straightforward. So we're going to do a quick comparison with what classical algorithms are and how they compare with machine learning algorithms. Okay, so classical algorithms are given exact and complete rules to execute a complete task. So it's just like you're telling a computer the real steps to go through to execute a task. So every time you want a computer to do or anything, you want a computer to execute that task, it is going to go through those exact and complete rules that you have set it up. But on the other hand, machine learning algorithms are given general guidelines that define the model along with the data. So we're going to start using this language, model and data, and it's going to be normal to you eventually. So the data should contain the missing information necessary for the model to complete the task. So a machine learning algorithm can accomplish its task when a model has been adjusted with respect to the data. So we say that we fit the model on the data, or the model has been trained to the data. So we shall look at some of these models, but what they're trying to say is that using machine learning algorithms, those algorithms learn with the data. Okay, so the more data you give them, the more data you train on them, the more they can maybe better predict a particular thing. We shall, okay, if it doesn't make sense right now, you're going to give it a minute, and then yeah, it will make sense. All right, so let's illustrate this with a simple example. Let's say we want to predict the price of a house based on the size of the house, the size of its garden, and the number of rooms it has. So we want to predict the price of a house based on the size of the house, the size of the garden, and the number of rooms. So if you see a house, it has a specific size of a garden, it's the size of the house itself, and the number of rooms it has. How can you easily say, okay, this house is probably going to cost this much with confidence? So we could try to build a classical algorithm that answers this problem. This algorithm would have to take 3 house features and return the predicted price based on an explicit rule. In this example, the exact house pricing formula has to be known and coded explicitly. So the formula is what they keep referring to as the classical algorithm. So you're going to say first, okay, I think they explain it further. So in this example, the exact house pricing formula has to be known and coded explicitly. But in practice, this formula is often not known, okay? So they're saying this is a classical example. You're trying to say, okay, how much is a house? This is the part where the $sign, how much is a house? And if you're going to use a classical approach, you're going to say maybe it takes on a formula of 1.2 times the size of the house plus 0.7 times the size of the garden plus 3.1 times the number of rooms in the house. But often we don't know how to come up with this formula. Like, where do you start from? Okay, so that is like a classical approach, a classical algorithm approach, where you put a definite formula, and that definite formula is supposed to give you an outcome. But how do you come up with this definite formula? How do you know the impact of the size of the house and the impact of the size of the garden and the impact of the number of rooms towards the price of the entire house? Okay, so this is the housing pricing formula. House pricing formula is known and explicitly coded. So this is the classical approach, okay? So on the other hand, we could build a machine learning algorithm first. Such algorithm would define a model that can be an incomplete formula created from our limited knowledge, right? So they're trying to explain like the process you would go through instead of having to use the classical approach where you know an explicit formula. We could try a machine learning algorithm to come up with the price of a house basing on the size of the house number of rooms, and the size of the garden. So first, when you're going with the machine learning algorithm approach, first, such algorithm would define a model. We shall see how you define a model and different types of models. So would define a model that would be an incomplete formula created from our limited knowledge. So you first create a model. This model is not going to be the very best at first, but it is going to be basing on our limited knowledge. Then the model would be adjusted by training on given housing prices examples. So you train this model by giving it different houses examples. Like for example, you get a known house, you see its size, the size of the garden and the number of rooms, and its price. That's a known example. You got several known examples, and then you train your model with those known examples. So by doing so, we are combining the model which we created with our limited knowledge of housing prices, and then we trained it on the data that we've collected from different examples. So that's what they mean here. Doing so, we combine the model with the data. So this is just a simple graphic approach, graphical illustration of just what we've just talked about. So this is the model with unknown A, B, C. So these are the coefficients like we saw above. In the classical approach, the coefficients of these, of the size of the house, the garden size and the number of rooms are explicitly known in the classical approach. But in the machine learning approach, these coefficients are not known. So that's why we need to train this model on known examples so that we can find these best coefficients. Okay? So this is the model with an unknown ABC to be defined. So this is the available data. So these are the housing examples I was talking about. So you get like 4. Of course, you get many. The more, the better. And then they have known, you know the size of the house, you know the size of the garden, you know the number of rooms, and you know what price those ones are. So this is the available data to determine the A, B, C, and D. So when you get these examples, you can come up with with these coefficients because you have examples of them. Okay? So of course, with the more data points you have, the more examples you have, the better these coefficients are going to be, and the better an unknown house will be predicted right. Okay? So in general, machine learning is incredibly useful for difficult tasks when we have incomplete information or information that's too complex to be coded by hand. So we have, I think this is really explanatory, self-explanatory. So we are saying that when you have a task that with incomplete information, or the information is too difficult to be coded by hand. For example, you have to have various variables for you to consider, for you to give you like an output. Machine learning would be very helpful for you. Okay, so in these cases, we give the information we have available to our model and let this one learn the missing information by itself. So yeah, again, we just give the model the information that we know, and then with more and more examples, it will learn what to do and how to predict better. So the algorithm will then use statistical techniques to extract missing knowledge directly from the data. All right. So that was just a simple introduction to machine learning, and then just generally what is machine learning versus the classical approach of writing just a formula. And yeah, so now we are going to go to supervised versus unsupervised models. So in this particular class, we are going to only dwell on supervised learning, and then Grace will come up and talk about unsupervised learning. So, but in terms of introduction, I'm just going to introduce both of them. All right, so there are two main categories of machine learning techniques. These two main machine learning techniques are supervised learning and unsupervised learning. So in supervised learning, we want to get a model to predict the label of data based on its features. So you're going to start having to use these keywords because that's what they are. And they have very many interchangeable words as you come to experience. But here we want to get a model, in supervised learning, we want to get a model to predict the label of data based on their features. In order to learn mapping between features and labels, so here features you could say or inputs, and labels could be the outputs. Okay, so in order to learn mapping between features and labels, the model has to be fitted on given examples of features with their related labels. We say that the model is trained on a labeled data set. So when you see this statement that the model is trained on a labeled data set, that's when you know it is supervised learning. So in short, it's like you're trying to train your model on known examples. So like going